AI is everywhere now. Need information? Click. Want to make an image? Just a click away. It's that easy. But with all this convenience, we often forget the complex processes behind it. AI isn't magic, but there is something magical in how it works. And to truly understand it, we need to look deeper at the logic, the math, and the systems behind it. When we look at handwritten numbers, we instantly know what they are. But for a computer, recognizing handwritten digits is incredibly hard. For example, let's say we try to write a traditional program to recognize digits by checking pixel positions. It won't work. Every person writes numbers differently, different shapes, different pixel locations. So regular code doesn't cut it. What we need is a system that mimics how our brains work. That's where artificial intelligence comes in, more specifically neural networks. Imagine you're deciding whether to hang out with friends. You think about the weather, whether your close friends are coming, and how far the place is. Each of these factors has a different weight in your decision. In a neural network, those weights represent how important each input is. There's also a threshold called bias. All of this goes through a formula, and the result is then passed through something called an activation function, like sigmoid, which outputs a value between 0 and 1. That tells us how active the neuron is. One neuron isn't enough. We need many, sometimes thousands. That's how AI can understand complex patterns. For example, to recognize a handwritten digit from an image that's 28 by 28 pixels, we'd have 784 input values. These go into the first layer of neurons, then the second, and finally to an output layer that decides what number it is. Now, to make this network smart, we need to train it. We use a dataset of handwritten digits, like MNIST, which has 60,000 examples. The AI makes a guess, and we compare it to the correct answer. That difference is called the cost or loss. We want to minimize it as much as possible. To do that, we adjust all the weights and biases using a process called backpropagation. Backpropagation is the heart of neural networks. It tells each part of the network how wrong it was and how to fix itself. Over time, with every training step, the network gets better. So while AI looks like magic from the outside, under the hood, it's built on logic, math, and lots of iteration. From input signals and weights to learning from mistakes, every part has a role to play. And this is just the beginning of what AI can do.